So we've seen a few examples of classes and constructors in C#. I'm going to look a bit more closely at constructors now. But before I do that, let's be clear on the relationship between an object and its class. The class definition may contain any data fields or variables that define an object, a string name, an integer value, or whatever. And it may also contain functions or methods that implement the behavior of an object. So if you have a room object, it might have a name and a description as fields or variables. And it might have a method called describe that describes the room, that is, a method that returns a string that shows the name of the room, its description, and a list of any items in the room, some of the treasures in the game, for example. Now, the class is the definition of an object. From one class, we can create many objects. For example, in a game, I might want to have maybe tens or even hundreds of separate locations. Each location, that is, each room object, would be an instance of the room class. The room class is the blueprint or template from which I create many different room objects. Each room object has the variables defined by the room class, but the values I assign to those variables are likely to be different for each room object. For example, this is part of the adventure game project that we look at towards the end of this course. Now, here I'm creating a whole list of room objects: a meadow, a forest, a glade, a grassy hill, and so on. Each room object has a different description and different exits, but they share the methods in the room class. So each room object can be asked to describe itself using the describe method. In order to construct each separate object from its class, I have to use the new keyword followed by the class constructor name. The class constructor is a special method that has the same name as the class itself. So, for example, the room class has a constructor method that's also called room. The constructor sets aside some memory to hold a new object, and it returns that new object so that my code can, for example, assign it to a variable of the appropriate object type. Now, I can't use an object until I've called its constructor. A constructor doesn't have to have any parameters. However, when an object has some internal fields, it's quite common for the constructor to define a list of parameters to initialize those fields. In that case, when you invoke the constructor to create a new object, you would need to pass the appropriate arguments to initialize those fields, the parameters defined in the constructor. When an object descends from another object, and the object from which it descends has a constructor that initializes some fields, the descendant class's constructor can call the ancestor class's constructor, passing to it any arguments required by the ancestor constructor to initialize its fields. It does that by putting a colon after the parameter list of the constructor, then the keyword base, then a comma-separated list of arguments between parentheses. Here, for example, is the game class's project from step 5 of the code archive. Here, room is a descendant of the thing class. Because the class is declared as room:thing, room inherits the name and description variables from the thing class, declared here as _name_description. But the thing class has its own constructor that initializes those variables. The room constructor simply calls base and passes the two strings needed to initialize those variables to the constructor of its base or ancestor class. Here, that's the thing class constructor. Then the room constructor goes on and initializes its own additional variables. Here, these are the integers that define the exits from the room. And whenever I want to create a new room object, I call its constructor after the new keyword and pass to it all the arguments required by the constructor. And then that returns a new room object.